Alright, Math 20-2, today we're going to look at the cosine law. As a quick introduction here, consider triangle ABC where angle A is 36 degrees, side AB is 3 centimeters, and side AC is 6 centimeters, as given to the right. What happens when you try to apply the sine law to determine the length of side BC, or lowercase a? That's what they're asked to find. So if I look at this, we learned last day that we need a complete ratio. So I know little side C, but I do not know angle C. I know little side B, but I do not know angle B. I know angle A, but I do not know little side A. So in this triangle, we do not have a complete ratio. So we don't have enough information for a complete ratio. So we cannot find the length of BC. Oh, we cannot use the sine law. To find side BC. Alright. So in the example above, when we're given the length of two sides and the contained angle, the sine law won't work. We haven't got a complete ratio. We can find the length of BC by making a right triangle BD, triangle BCD, sorry, in the diagram below, and using our right angle trigonometry, our basic trig ratio, sine, cosine, or tangent, to find the lengths of CD and AD. So let's turn the length of CD in the diagram drawn. So in that right angle triangle, I know this angle is 36 degrees, angle A. We're looking for the side opposite angle A, length CD, and we're given the hypotenuse now in that right angle triangle AC. So from 36 degrees, if I'm looking for opposite and I'm given hypotenuse, I would say that's the sine of angle A, which is 36 degrees. So that equals side CD, the opposite side, over the hypotenuse, which is 6. So to find the length of CD, I multiply both sides by 6. 6 times the sine of 36 degrees, give you the length of CD. You do that with your calculator, we'll come up with a measurement to the nearest tenth. Let's round to 2 decimals, 3.53 centimeters for right now. We won't round till our final answer. Alright, so this is 3.53 centimeters. And now let's also find the length, excuse me, it says we can find the length of AD. So let's do that. From 36 degrees, AD is adjacent, and 6 is the hypotenuse. So I would use my cosine ratio. The cosine of angle A, 36 degrees, would equal my adjacent side, length AD, over my hypotenuse, which is 6. Again, multiply both sides by 6. And use your calculators, and we now know the length of AD. 6 times the cosine of 36 is 4.85. So this whole thing from here to here is 4.85. So I could find the length of little side BD. 4.85 subtract 3. So side BD should equal 4.85 minus 3. So that gives me 1.85. Centimeters. Now that I know two sides in my new triangle here, I can find my third side, side BC, which is what we were looking for. So I'm going to use Pythagoras Theorem. I've got two sides of a right angle triangle. I can find the third side. Pythagoras Theorem states that the square and the hypotenuse, which in this case is side BC, should equal the sum of the squares of the two sides. So 3.53 squared add 1.85 squared. So if we do that, use Pythagoras Theorem, let's figure out what the length of BC is. So you can use your calculators. I'll let you do that. And we should come up with BC being a length of, if I round it, 4.0 centimeters. Alright. And I believe that's what this question asks us to find. Find the length of BC. So we had to do 3 calculations. We used right angle trigonometry to find length CD. We used right angle trigonometry to find length AD. We subtracted those to figure out the length of BD, and then we had 2 sides in our new right angle triangle. We used those 2 sides to figure out side BC. That's a lot of work. 1, 2, 3, 4 calculations to get our final answer of BC equaling 4 centimeters. All right. You would think there's got to be a better way. And, of course there is. We call it using the cosine law. So, the cosine law states in every triangle ABC, the sides labeled A, B, and C are in this situation. A squared equals B squared plus C squared, which kind of looks like Pythagoras Theorem, but we're going to subtract from that 2 times B times C times the cosine of angle A. The important thing to remember in this cosine law, if side A is on the left side of this equation, then the angle opposite that is what we're taking the cosine of. All right. So these are labeled as A, lowercase a, and capital A. That's very important to remember that. Here's the proof to the cosine law. The diagram shows triangle ABC placed with base AB on the x-axis. We can see that on the x-axis, and the origin is at point A. So here's the origin at point A. The line CD is drawn perpendicular to AB and is h units in length, so that's been labeled. We know it's right angle perpendicular. AD is x units, so we know that DB has to be C minus x because the length of AB is lowercase c. That makes this C minus x. All right, so from A to B is lowercase c, opposite angle C. Complete the following work to show that this is true. A squared equals B squared plus C squared minus 2BC times the cosine of A. So in triangle ADC, this triangle here, ADC, the cosine of angle A, from angle A, the cosine would be length AD over length AC, adjacent over hypotenuse, which is x over B. Great. So if I wanted to solve for x, I would multiply both sides by B. B times the cosine of angle A. In triangle ABD, triangle BDC, we know Pythagoras theorem states that the hypotenuse squared BC squared should equal the sum of the squares of the two sides, CD squared plus DB squared. So let's write in the things we know. We know that BC has a length of A, so A squared equals CD has a length of H squared, plus BD or DB has a length of C minus X, all squared. So if I expand out this bracket, I square the first term, C squared, multiply the two terms together, C times negative X, so minus CX, and you double it, so there's your minus 2CX, and then you square the last term, negative X times negative X is positive X squared. Now let's simplify this bracket a little bit, or this right side of this equation a little bit. H squared plus X squared plus C squared minus 2CX. They just put the X squared and H squared together in brackets. X squared plus H squared, if we look up here, X squared plus H squared will be the same as b squared in this triangle using Pythagoras' theorem. Alright, so x squared plus h squared, we could rewrite that as the hypotenuse squared, the sum of these two squares on those two sides. So x squared plus h squared is the same as b squared plus c squared minus 2c times x. Well, we just found out x is over here, and that equals b times the cosine of a. So in this bracket for x, I'm going to write down x equals b times the cosine of angle A. So if I now look at what we've got written, a squared equals b squared plus c squared minus 2c times b is the same as bc times the cosine of a. So we've just proven that formula. Now by placing AC and then BC on the x-axis, similar equations can be derived. These are the exact same law. These are all cosine law equations. They're just rewritten. The important thing to look at these and recognize is little side B and cosine of angle B. Look where they're located. Little side C and cosine of angle C. Look where they're located. That's an important thing to remember. Note, this version of the cosine law can be used in any triangle if we're given the lengths of two sides and the contained angle. Alright? So anytime we're given two sides of the contained angle, we're going to use this version of the cosine law. Let's go to page 169. Let's look at example number 2. Consider the triangle ABC from our first class example, where angle A was 36. Side AB was 3 and side AC was 6. Find the length of BC using the cosine law. So the length of BC is lowercase a. If I want to use the cosine law, I'm looking for lowercase a. I need to know the angle opposite. So angle A is 36 degrees. So if I want to write the cosine law, a squared equals b squared plus c squared minus 2bc times the cosine of angle A. Well, I'm not sure what A is. That's what we're asked to find, length BC, so that's our unknown. I do know B squared. From angle B, 6 would be considered little b, and 3 would be considered little c. So let's plug those in. B squared is 6, so 6 squared. C is 3, so 3 squared minus 2 times b times c times the cosine of angle A. Angle A is 36 degrees, right? So if I look at that equation, there's only one unknown. All the rest of the equation has been filled in. So I could do that calculator work, find out what a squared is, and then take the square root of both sides, and I know what a is. So let's do that calculator work. So a squared equaled 6 squared plus 3 squared minus 2 times 6 times 3 times the cosine of 36 degrees. You press enter, and that is not the value for a, that's the value of a squared. So we must now take the square root of that answer to figure out what a is. So a is 3.98, or if we round to the nearest tenth like they asked, that's 4.0. So a squared is 15.88 and a is 4.0. 15.88, and this is 4.0 centimeters. Alright, so we get the exact same answer we had, but we only had to do one equation and one calculation. Use our cosine law. Substitute into that law and use our calculators. So let's consider triangle PQR shown below. Complete the cosine law for calculating side Q. So let's write down the things we know. If this is angle Q, here is side Q. Angle R, this gives us side R, and angle P, opposite that is side P. So if I want to use my cosine law to solve for Q, we would say Q squared equals P squared plus R squared minus 2 times P times R times the cosine of the side opposite side Q, sorry, the angle opposite side Q, which is angle Q. Now calculate the nearest tenth length of the third side in this triangle. So we know that QP is 1.7. Let's label that. We know that QR is 3.1. And angle PQR right here is 110 degrees. So if I know those things, I'm finding the third side, which is labeled as side Q. We rewrote the cosine law to solve for side Q. So we'll substitute in that law. Q squared equals P squared, which in this case is 3.1. Add R squared, well R is 1.7. Minus 2 times P, which was 3.1, times R, which is 1.7, times the cosine of angle Q. Angle Q, we're told, is 110 degrees. So every time I want to see the substitution into that formula, and then it's just calculator work. All right? So once you can substitute that formula, the rest is calculator work. I want to see the substitution, and then you can do the calculator work. So let's do the calculator work. We've got 3.1 squared, add 1.7 squared, minus 2 times 3.1 times 1.7 times the cosine of 110 degrees. Now that is not the value for Q, that's the value of Q squared. So we must take the square root of that, second function square root of that answer. So we're going to get 4.0 centimeters. All right. So Q is 4.0 centimeters to the nearest tenth. All right. Let's try example 4. Bellevue is 30 kilometers north of Ayr and Churchville is 18 kilometers north of Ayr. Calculate the distance between Bellevue and Churchville to the nearest kilometer. So I'm going to use some letter abbreviations. Bellevue is 30 kilometers north of Ayr. So here is Ayr and here's Bellevue, 30 kilometers north. And then we're told that Churchville is 18 kilometers northwest of Ayr. So northwest is 45-degree angle, 18 kilometers. And that's Churchville. Find the distance between Bellevue and Churchville. We're looking for that distance right there. So there's my triangle. I'm looking for lowercase a. I know lowercase b is 18. I know lowercase c is 30. And this angle, we said, is northwest. So north and west meet at 90 degrees. If it's at northwest, that's an angle of 45 degrees, exactly halfway between north and west. So half of 90 is 45 degrees. All right. I can now use my cosine law to figure out the length from Churchville to Bellevue, or lowercase a. So a squared is going to equal b squared plus c squared minus 2bc times the cosine of angle a. I've drawn my diagram. I can just substitute in now. So into this formula, little b is 18. So 18 squared, add little c was 30. Minus 2 times b times c times the cosine of angle A. We said that's 45 degrees. Northwest is a 45-degree angle. So I've substituted in. I just have to do the calculator work now. All right. So if a diagram is not given, you want to draw a diagram. You don't have to write the formula every time, but I want to see the substitution into the formula. Then I want to see the final answer. So that's calculator work. So let's do that calculator work. So we said that is 18 squared plus 30 squared minus 2 times 18 times 30 times the cosine of 45 degrees. Again, that's the answer for a squared. We want to take the square root of that to find the length of side A, or the distance from Bellevue to Churchville. So it says to the nearest kilometer, 21.455 would round to 21 kilometers. 21.455. And now I should answer the question. It is 21 kilometers from Bellevue to Churchville. All right, so one more mark to answer the question. Great, let's move on to page 170. An alternative form of the cosine law. The equation a squared equals b squared plus c squared minus 2bc cosine a is the cosine law, and that's great if we're looking for a side. All right, but if we're looking for an angle, we can rearrange the formula to find an angle. So I can rearrange that formula to solve for the cosine of a. So if you want to do that with me, from this equation, we're going to rearrange it and come up with that one. All right, so let's do that. Step 1, I'm going to add 2bc cosine a over to that side, and I'm going to minus a squared over there. So they're going to switch places. So I now have 2bc times the cosine of angle A, and that equals b squared plus c squared minus a squared. Right? So I subtracted a squared from both sides, and I added 2bc cosine a to both sides. And now if I want to solve for cosine a, I divide both sides by 2bc. And we get this equation. That's gone. Cosine a equals b squared plus c squared minus a squared all over 2bc. Now that one may not be given to you. You might have to know how to derive that. But this form of the cosine law can be used to determine any angle in a triangle when we're given the length of the other three sides. So if you're given side, 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 we can figure out any angle measure in that triangle. If I want to solve for angle B or angle C, complete the following. So again, let's take special notice of where the letters fall. If I'm looking for angle A, look where side A is. If I'm looking for angle B, my cosine law would become a squared plus c squared minus b squared over 2ac. Again, take special note of where the B angle and B side is. If I'm looking for angle C, then my cosine law should state a squared plus b squared minus c squared all over 2ab. So again, take note of where angle C and lowercase c reside in that formula. Example 6, determine the largest angle in triangle ABC if you're given these three sides. Note, if you're ever asked to find the largest angle, the largest angle is opposite the largest side. So if I want to draw this triangle, maybe it looks like this. The largest side is lowercase a, so 14.7. That makes this angle A. Lowercase b is 8.9. So that makes this angle B. And lowercase c is 12.6. So that makes this angle C. So the largest angle in the diagram I just drew is opposite 14.7. So we're looking for angle A. So to write this law out then, I would say the cosine of angle A should equal b squared plus c squared minus a squared over 2bc. Alright, so let's substitute in that formula and then use our calculators and solve for angle A. So the cosine of A is going to equal b squared. Well, opposite angle B is side B, so b squared is 8.9, 8.9 squared. Add c squared, c is 12.6, minus a squared, which was the longest side, 14.7 squared, all over 2 times b, 8.9 times c, 12.6. So again, if we do this calculator work, we get the value for the cosine of A. We will not get the measure of angle A until we do second function cosine. So let's do this calculator work. Make sure we can do it correctly. Here's what it should look like. In my numerator, let's put that in brackets. In my numerator, we have got 12.6 squared plus 8.9 squared minus 14.7 squared. That's all the numerator. So put that all in brackets. Divide that by our denominator, 2 times b times c, which is 8.9 times 12.6. And close that bracket because that is our whole denominator. And we get this decimal value, 0.097556. 0.098 we'll say. So the cosine of A is 0.098. That is not the measure of angle A. To find the measure of angle A, we have to go second function cosine of that ratio, 0.09755, 66256. And that answer gives us the measure of angle A, which is 84.4. So it doesn't tell us what to measure this to the nearest one, so we'll say 84.4 degrees. All right, so that's the measure of angle A. Last example then, example 7. Two ships set sail from port P heading in different directions. The first ship sails 7 kilometers to R, second ship sails 8 kilometers to Q, and if the distance between R and Q is 13 kilometers, what's the angle between the directions of the two ships? Well, the first ship sails from P to R, so here's where the first ship's sailing. The second ship sails from P to Q. Determine the angle between the directions of the two ships. We're looking for this angle. Alright. So I want to write out my formula for this case. If I'm looking for an angle, I'd say the cosine of angle P is going to equal Q squared plus R squared minus P squared over 2QR. And in this triangle, the side opposite angle R is lowercase r. The side opposite angle Q is lowercase q, and the side opposite angle P is lowercase p. So there are our sides. We just have to substitute into this formula then. The cosine of angle P should equal Q, which is 7 squared, plus R, which is 8 squared, minus P, which is 13 squared, all over 2 times Q times R. Calculator work. Let's do that. So we have got 7 squared plus 8 squared minus 13 squared. Now I didn't put this in brackets, so let's make sure we do that. Make sure you put your numerator in brackets. So I better go back to the start of this statement and insert that bracket. So 7 squared plus 8 squared minus 13 squared divided by, and in my denominator I should put brackets, 2 times 7 times 8. Close the brackets in my denominator, and you're going to get a decimal value. Negative 0.5, again, that is not the value of angle P, that's the value of cosine of angle P, so you must go second function cosine of that answer. All right, so the cosine, second function cosine of negative 0.5 is 120. So angle P is 120 degrees. Let's answer the question. The angle between the directions of the two ships is 120 degrees. All right. So what do you need for every question you do? If a diagram's not given, you should draw a diagram or label the one you're given. Substitute into a formula, solve for the unknown in that formula, and then answer the question. So expect that done every time you do these questions. All right, so you have your assignment. Away you go.